Overall. Alrighty. All right, it's about 7:30 on the dot, so we'll get started here. I'm sure some people will come in late, and if any of you have to leave early, no problem. Just shoot out the door quietly, and that should be perfectly good. All right, everyone just find yourselves a seat and sign in. I'll leave this up for anyone who's sitting or hasn't signed in. Please do this. This helps us get feedback. There's another one at the end for sign out to give us feedback on how the presentation went. Allows you to recommend new topics you'd like us to see, and I'll do my best to comb through those. And if I can find an expert in the field that I can bring in, I'll make sure to do that. Good afternoon, everyone. My name is Ethan Hoban. I am the president of the Theta Eta chapter of Eta Kappa Nu. That is the IEEE Electrical Engineering and Computer Engineering Honor Society. We host this Tech Talk series. This is our 5th talk this semester. Overall, I think this is the 11th talk now. We have a YouTube channel as well, where all these talks are fully recorded. We post all of them on our YouTube channel, so we've got a whole cool backlog. I can share the link with everyone at the end. If you fill out that sign-out sheet, I'll have your email. I'll make sure to shoot you all the link in case you're interested. We have a whole bunch of cool stuff: guidance and control, AI, machine vision, stealth design, all the cool stuff. So, is everyone signed in? Everyone good? All right. So, I will do a brief. Oh, wrong button. I will do a brief introduction of our speaker, and then he'll take it on. So tonight, our speaker is Cummins Aerospace Senior Software Engineer Sean Mitchell. So let's give him a hand. And
Alrighty. So before we start, just a little bit about me. Like Ethan said, I'm a lead software engineer, senior software engineer at Cummins Aerospace. I've lived a few lives here in the defense industry, Georgia Tech, Research Institute, Leidos, Kratos, a couple of others. Professionally, I'm a robotics engineer. I do a lot of robotics, AI, ML, guidance, navigation control, software architecture, and design. I'm a UAH grad of 2020, minor in CS. I'm finishing a master's here in spring with a focus on dynamics and AI, ML, and robotics, and looking toward a PhD in EE here next year, starting that. So I'm been around the town. Most of my jobs have been associated with small unmanned aerial systems like this. I've worked on things a little bit bigger, a little bit smaller, quadcopters, fixed wings, whatever. So I have a lot of interesting experience that we'll talk about tonight. So tonight, just a history of unmanned aerial systems, some of their application, mission profiles, a system of systems approach, which is how I tend to think of things when I'm designing or given a task to design something that's an unmanned aerial system. Some practical design considerations and maybe some points of view that you hadn't thought of if you don't work in this space all the time. And we'll do a kind of a hands-on case study of this thing here. This is the Hellhound S2. I work on the next generation of this, the S3, but I'll go into how this works and kind of some cool things about it and what I do at my job. Then talk about next steps and readings and Q&A. So just a little bit of disclaimer. Nothing here is going to be classified or proprietary company stuff. This is all practical experiences, white papers, textbooks. This is just CYA, so I don't get a visit from someone that's going to make me forget what I'm doing. So, what is a UAS? It's an unmanned or uncrewed aerial system. It's a family of air vehicles whose primary attribute is that they operate without an onboard crew. Does not mean they operate without humans. There can be humans in the loop, but primarily these don't have people on them. And what can they do? Well, anything a crewed aircraft is going to do, and then some. Like all robots, they're really useful at being put into situations where you don't want to send someone. As an example, humans are fragile and expensive. The dollar cost to train a pilot varies plane to plane, but the range is between $1 and $10 million US for the Air Force, which is wild. $1 million for a cargo pilot, but you put in a fighter pilot, you're looking $5-10 million to do training, logistics, all that fun stuff. And drones can be extremely cheap. That link there, it's a disposable assets, is a $9 quadcopter on Amazon. No, I don't think that works well, but it is that cheap. You have a $9 quadcopter cost, it's available. So yeah, like I said, they can perform tasks that are too dangerous for humans. In general, UAS come in two major subfamilies, fixed wing and rotorcraft. This thing in front of you is a fixed wing, and a rotorcraft would be more like a quadcopter, more like this thing. They come in, 4, 6, 8, multiple configurations depending on how much you need to lift and what your mission profile looks like. So a little bit of interesting history of UAS in case anyone didn't know some of these. I didn't know all of these until I was looking into it. Apparently in 1849, Austria used unmanned balloons to carry some bombs against Venice. So that's kind of the first attempt at having an unmanned aerial system. I guess it didn't work that well because we didn't do anything more with that until about the 1900s. But there was some initial experiments with radio-controlled aircraft. As always, the World Wars had a lot of technological development very quickly. You know, World War I, we saw some pilotless aerial torpedo, and that's the link to that. I think that's the Kettering bug there on the right. By World War II, we had several early attempts at unmanned combat air vehicles out of the UK and the US. Some of these were used for practice, gunnery practice. Some of these were actually deployed as, you know, a reason to, you know, be used. So by the Cold War, obviously, things are, you know, getting more intense there. There's an evolution of UAS into reconnaissance platforms, and you'll see that as a trend that because they can stay up for, you know, days or even weeks and months at a time, they're very useful for ISR and various reconnaissance activities. You can think of an analog to a U-2 spy plane with some of these. We deployed the Firebee for surveillance over Vietnam and China, and we're starting to get remote sensors and cameras that were introduced, paving the way for modern intelligence and reconnaissance missions. By the modern era, the 90s and, you know, to present there, we have things like the Predator, which becomes a key reconnaissance and later armed platform that really revolutionized military UAS use. That's one of those that still is used and still is very prominent. We also saw civilian and commercial UAS emerge with improved sensors, autonomy, and affordability. This is where you start getting into your $9 Amazon quadcopters. And nowadays, they are used for a lot of things that aren't military stuff. Things you might not think of. Agriculture, mapping, emergency response, logistics, and research too into aerodynamics. So this is, you really can't escape these. Sometimes that's a literal statement. So as I've said, UAS has been around for a few minutes. Like robotics in general, the systems provide an incredible variety of capability for many applications. I have an ongoing conspiracy theory that we're a mere handful of years, and you might debate me up to decades, but I still think years off from more or less phasing out frontline pilots and air combat completely. I think the next generation of air combat is, you're not going to see people on the front line with that. I think the capabilities are getting too extreme. So before we go and I rant about that, let's take a deeper look at what missions we can accomplish with UAS. So, you know, obviously I work in defense, so I think mostly of UAS in military applications. You know, you have your intelligence, surveillance, and reconnaissance. That's kind of what it sounds like. That's looking for information. That's looking for, you know, information about assets, what can be done, what they're doing, and if you can send in something else necessarily. And, you know, I won't go too deep into that because some of that gets into, you know, sus territory from a classification perspective. From an offensive perspective, you have, you know, tactical strategic strikes. That's exactly what you think it is. Can you fly around, send a missile at something? You have hunter-killer type profiles where you might have two planes, one acting as a hunter and one acting as a killer, or even both those systems on the same vehicle, a camera telling a missile to fire off of a platform. Kamikaze drones, that's what this thing in front of you is there. They're designed to go out and not come back and hopefully take someone with them. You also have loitering munitions now. That's something that's becoming very popular in the industry, and I've worked on several contracts to support those profiles. A loitering munition goes up and it sits there until someone says, hey, bring it down on someone or something. And you also have jamming and electronic warfare platforms now, because that's also a very hot topic of put something up that can scream or jam or be a problem for someone else's sensors. On the defensive side, missile defense, you can hit some missiles with drones. It depends on, you know, your type of drone and what you're doing with it and the type of missile. Close and asset defense, thinking of something like you might put this on a hard point of a boat or a base, the ability to go up and intercept another drone, a missile, something that is in the air. Counter UAS is also a big field. That's something else I've worked on some contracts with because as ubiquitous as these drones are becoming, we need a way to put them down. Area control and keep out, if you're an aircraft, if you're manned or otherwise, and you know there's a bunch of drones in the area, especially ones that do have a CUAS capability, you probably don't want to be there. And then logistics too, resupply and communications. I'm sure some of you have seen Amazon is now delivering packages via drones, and the military makes use of that, and would definitely like to make more use of that. Sean writes the Global Hawk. That's a very popular high altitude. This one's remotely piloted. It's not, you know, it has autonomy now, but back then it was pretty much a, you know, playing Call of Duty type of thing. So for civilian applications, I've worked on some of these too. Power line inspections, bridge inspections. I worked on a couple of contracts that talked a lot with the Department of Transportation that were interested in some tethered drones. So drones attached to the back of vehicles that could bring data links and power that they could send a truck out and have it go up, and instead of having a man on a ladder or a ladder truck, it could do very precise measurements of is there bridge damage, is there power line damage, and even make repairs. You also see it in agriculture with watering, pesticides, testing, the ability to go out and have something automatically, explore, see what's happening, do pest control, all that fun stuff. Disaster relief is another one where you see a lot of robotics and disaster relief in general, because it's honestly safer to send a robot into a debris pile than it is a human. But you also, that you see that there, but you also see a lot of temporary communication networks. You can put a lot of quadcopters up and they can act as a portable cell network for an area that goes out during a disaster, which can be vital to relief crews. And then geography, mapping, climate change, all that stuff there, the ability to send drones out and have them, map mass areas over years can be very important to, how is the climate changing, how, what's happening in an area, long-term effects, stuff that you wouldn't want to have some guy flying around in a Cessna every day for 6 years to try and do. We don't care about robots yet to, you give them that luxury of a break. And also, I know it says space UAS, but we've actually done things in space with unmanned aerial systems. The top right is the X-47B there, which is a space plane that goes up and lands a lot like the shuttle did there. But it sits up there and does lots of things that we don't know about, and that probably should concern you, but it's run by the U.S. Air Force. And bottom right is the Ingenuity. That's the helicopter we sent to Mars that flew on Mars, and so aerial using very generously there. But, we've done things in space with these systems too. The principles still apply. And these are very interesting vehicles too. You should actually take some time to look at them at some point if you're interested. So, unmanned aerial systems. When I think of unmanned aerial systems, to not get bogged down in the complexity of them, I try to think of them as systems of systems, the Lego block approach of building up something that comes from, a sum of its parts. They're not just robotics aircraft, and that's not a wrong way of thinking about it, but they're a lot more than that. You can see there's some of what make up a UAS: airframe, payloads, power, GNC, communications, ground control, command and control, so many more things. That's scratching the surface of what makes up these systems. And it's very easy to go, oh, well, it's overwhelming. Well, it's less so if you have a focus. My focus has been much more in guidance, navigation, control, sensors, communications. I don't necessarily do airframe design, but I know people who do. If I did everything, then I'd be very swamped. So kind of talking about the airframe and some of the things that make it up there, they come in a lot of shapes and sizes. Obviously, I've shown some pictures of some bigger ones at the size of aircraft, and this thing here is 2 to 3 feet, roughly. And again, they also, come in fixed wing, rotorcraft, lots of different ways to configure these things there. For the physical body of the air vehicle, and the airframe would have said a lot of things about your overall performance and how your system is made up. Hard points, which are, the A-10's not a drone, it's not a UAS there, but it's just a very good example because it is just a flying hard point. But that's essentially where you can mount payloads. In the A-10's case, that's just guns. But the airframe would decide, flight capabilities, speed, max altitude, operational roles, what you can do with it. And that will become a major design trade space as you, start to make design choices. So, moving from the airframe, how do you move a UAS? Lots of common choices here. Jet engines, this one here in front of you today, uses a turbojet off the shelf. You can do things with propellers, you can do things with EDF, electric ducted fans, and rocket motors. I've seen some that, launch or just utilize rocket motors for some extreme maneuvers. Each of these come with a long list of pros and cons, but, price, noise, output, power requirements, space, detection, cost. If you have a very silent motor that's, electromagnetically or from a noise perspective, that makes you a little more stealthy, a little more easier to get by something. But it may come at the cost of speed, and some of these come at the cost of, higher fuel consumption or max altitude or what they can work in. So I've seen systems that use hybrid approaches, rocket launch that turn into turbojets. So a lot of space to maneuver here. This is very much an aerospace type of application, and if there's any aerospace engineers in the room there, a lot you can do with this, and a lot of unconventional things you can do with propulsion for UAS systems now. So moving from there, power, of course. There's a lot of ways you can power these things. Depending on your choice of motor or engine, you may be able to actually have, generator, alternator, and power it off of that. You can also power off of batteries. Those little lipos that I'm sure most of you have seen at this point are really good, and that thing flies off some of those for internal power. They're cheap, they're available, and they can have very high energy storage and output. But obviously if you have more complex machinery, you're a bigger plane, you're a global hawk, and you want to have a long duration mission, maybe you should be powering yourself off of, fuel. And obviously this kind of extends to how do you power your, one of your engine choices here. Are you carrying a battery, or are you carrying, a big bucket of jet fuel? Because jet fuel is volatile. You also use solar panels there. If you're a high altitude, long duration mission, it may behoove you to put some solar panels on the top of your plane and just hang out there where sun's readily available and just keep some batteries charged, depending on what you're trying to do. Typically for, low altitude stuff and, stuff that's more disposable, you wouldn't want to do that. But payloads, this is where, kind of is what you think it is. The ability to pick stuff up, carry it, attach it to hard points, what comes on your drone. I tried to focus here with, things that aren't just guns. You can carry logistics, the bottom center bottom is one of Amazon's, things that will show up at your doorstep now and not look intimidating at all. But there's a lot of things you can put on UAS because, again, it's a plane. These include, additional measurement sensors, communications, electronic warfare, cameras, ISR tools, and, of course, armaments of many types, lethal and non-lethal. The ability to do crowd control is something you see with some drones in various countries and cities now. They're, pellet guns, nets, things like that. But, of course, you can put a gun on it, put a missile on it, put a laser on it. The next thing here is, something I work a lot in, guidance, navigation, and control. This is a field of engineering that describes how you automatically get where you want to go. And we actually have a nice lecture that we did previously from the Tech Talks. There, I've linked a couple of the previous ones we've done that are relevant. But in a high level, people will also call this an autopilot. Depends on who you talk to. If that's a wrong or offensive term, I think it's probably pretty accurate. But basically the cliff notes are navigation is where you want to go, guidance is how the computer says you're going to get there, and control is what your vehicle needs to do to get there. So, I want to go across the room, it builds a solution off of that, and then the controller says, oh, you need to turn the engine this fast, or rotate this fast, or bank in this way to do that. Your intuition this is very similar to the cruise control in your car. It's taking measurements, feeding back on itself, and adjusting in real time to meet the desired set point. Regardless of the level of autonomy your UAS has, some amount of GNC is occurring. I don't think there is a aircraft, UAS or otherwise, that is made that has no fly-by-wire, no automatic GNC, no autopilot assistance. I'm sure that someone has made one, but in production and actuality, I don't think anyone's just taken it, by itself with no assistance. If they are, that's a good pilot. I'm very impressed. As I was talking about autonomy, even if your drone is completely autonomous, human off the loop, it still needs to communicate sometimes. It has to get something, from somewhere, some point there, even if it's in pre-flight, that says, hey, go do the thing. Otherwise, it's just kind of flying around ambiently. Communication could be telemetry, it could be commands, it could even be acting as a repeater for another UAS. That's something that you do see in a lot of tactical and strategic applications, is the ability to piggyback communication signals off of different drones from long distance stations, especially stuff that's over the horizon type of communications. That's helpful when you have GPS denied type situations or contested spaces. And then, of course, command and control systems, going, where do your communications come from? It's a vital component. How do you interface with these? And they come in a lot of shapes and sizes. These can be entire facilities across the planet. They can be mobile command points. They can be handheld devices. Be phone apps. I've worked on some phone apps that are, you tell it go over there and hit that guy or whatever there, literally install on your, Samsung device. I've seen some that are like a Nintendo Switch size, and some that, again, entire facilities or something like this where you have multiple people with the joysticks doing all the fun commands. So there's a lot that comes to command and control. There's also integrations with things like tactical networks and some of the stuff that exist to have inter-asset communication and, battle space management and understanding. And of course, ground control or ground support systems, GCS there. This is really what keeps the U.S. able to perform, because if it's not a kamikaze drone, ideally it comes back. If it doesn't, then someone may actually have access to technology you don't want them to have now. These systems and people, perform maintenance, fueling, loading and unloading of payloads, repairs, because like all mechanical things, they break down, and pre and post flight operations. I've known people that work in this space on flight crews, and very competent people, and people you need to listen to, because no one would tell you why your plane doesn't work better than a technician. So let's talk some design considerations. This is kind of a fun topic. So, we have a little bit of intuition now that these are systems of systems, and there's a lot of different, systems inside them. So how do you make a design choice when you have so many interacting systems? If you change your wingspan to fly longer, it might directly change what airfields you can land at. Not all airfields can handle planes of the same size. If you think of a, international, jetliner there, that can't land at a dinky little field in someone's backyard. So we're not really gonna go into an exhaustive list here. We'll hit some of the high points. You could make up infinitely small subsystems out of these, and you could teach courses and make careers out of this. But the analogy I use is, did you ever consider how changing the voltage regulator to support higher voltage on that data link would affect the total power margin of the aircraft and require a larger battery, which means we need a longer charging time between flights, but also carries a higher risk of fire if it crashes. Also, that bigger battery might add weight, which means we need bigger engines, which means the airframe needs to be redesigned, which changes the overall aerodynamics, ... So there's a lot of things that are small that you can think of that go, oh yeah, well, this is now going to have a big impact, and this is why you have teams. It's very cross-functional. If you don't like working with people, this is not the field to go into. I can tell you that right now. So again, airframe design. This is going to be a very big driving factor, and a lot of it's going to be based on what you want to do with your plane. We know from general aviation, shown on the right, a 747 looks a lot different than an F-22. There's a lot of reasons for this, of course, but these support very different roles, and they act very differently and behave very differently. You want longer range, you may want a wider, more stable wingspan. You may want something that hangs out there. You don't want to have to be fly-by-wiring, twitching all your control surfaces constantly. But a higher maneuverability, you may want something like an F-22. Heavier payloads, well, bigger engines. If you want to carry, some of the biggest bombs in the U.S. military, then you're not going to do that on, something like this thing here. You won't be able to take a hit. You want to be tough? Well, you're going to need a tougher airframe. You don't want to be knocked out of the sky if it's high value. And your design of your airframe has, because of hard points, that controls sensor complements and payloads you can put on it. If you don't have a place to mount some of these things, then you're not going to carry them. Or if you have to have something like a sensor pod under a wing or under a vehicle, well, that changes your aerodynamics, and you may have to compensate for that. And it's more than just aerodynamic performance too. Max weight, available power, and data connections all impact your design. And that's something that for my fellow electrical and computer engineers in the room, the available power and data breakouts are critically important. Of how many of those do you have? What language do they speak? What kind of payloads do you want? Are the payloads modular? Are they swappable? Are those the same things? They are not. Modular and swappable payloads are different. What kind of interface do they use? Common standards? What kind of maintenance do these sensors actually need? For the record, a modular payload is something where you can drop pieces in and out, but a swappable payload is quite literally you take it off and put a different payload on with that same interface. There's a subtle distinction there, but there are people in the Army that will point that out to you very, very aggressively. Those are different terms. A pro tip is you want to be as compatible with as many things in your subsystem space as you can be. You do not want to be that one drone that requires that really specific jet fuel that you can't find outside the lab, or that one component that you have to go to them to. I know companies like to do that, obviously. They want to have you locked in their proprietary ecosystem, but that's not what gets you contracts. That's not what makes things work. That will lose you money. So again, power and interface. And this is something that's becoming more important because we're getting more interesting toys and more interesting payloads. Obviously, your sensors require power, data interfaces, but what about payloads that need all the power? What about things like directed energy weapons and electronic warfare? Some of those can require significant power to transmit electronic warfare or have directed energy, and this is where you see stuff like I've worked on tethered drones that could support some amount of directed energy because the tether that was going back to the truck supported 1200 volts going up of it. So you can do a lot with that. And if your system needs to support those, it's more than just a bigger battery, because you really don't want to be flying just a bunch of car batteries on top of your drone. Maybe you do, I don't know, that seems like a bomb to me. It's a power source, it's power conditioning and transmission. You know, if anyone's familiar with high voltage and power systems, there's a lot to do there that are not just put more voltage into the line. You know, a lot of wires and traces will straight up explode if you put enough voltage into them. Appropriate wire gauges, antenna waveguides, optical trains, all these things factor into this. Shown on the bottom right is the Yaw 1, I guess, but it was a early attempt at airborne laser missile defense, and it actually worked pretty well. It was expensive, that's why we don't do it. It used a gas laser system, but we have put things on the sky that actually do significant damage. I think it was a ballistic missile defense system. It was an attempt at that. We only made a couple of them, but you know, as we get more, as power systems evolve and battery sources evolve, the ability to use directed energy and electronic warfare becomes a lot more available, and also becomes something that's great for counter UAS, because you're not going to dodge a laser. This is not Star Wars. It does not, the photon does not move slowly through space. It's moving at the speed of light, and all it has to do is burn out one of your propellers or part of your wing, and you're done. So, like everything, cost matters in this, you know. And I would really love to tell everyone in this room, you're never going to have to worry about how much or how little a widget or something costs, but you will. I'm not going to lie to you. You will definitely have conversations that say, hey, we want this computer because it would be great, or we want this engine or this fuel because it'd be great. And you're going to have conversations where you have to go with something that's lesser. The defense industry is a little more flush with cash, depending on who signs your paycheck. But at the end of the day, everyone wants the $25 computer that runs HAL 9000, and that's a true story that I can talk about later if people are interested, of a legitimate conversation I had with a customer. The general art of engineering is knowing what you can live without, or exactly how long you can live without it. For very short and simple things, you know, a 5-minute flight for a kamikaze drone, you can live without a really nice computer. But for something that's going weeks and months and is doing a lot of computation, can you really live without that? Yeah. You know, at the end of the day, we're engineers, and that means we solve problems, and sometimes we create our own problems to solve. So this is kind of part of the job and part of the field of figuring out what you live without, what you don't want to live without. So, since engineers make things, usually, you should be very concerned with how easy it is to make your UAS. I can tell you that that is a huge thing right now for the Army, the Air Force, the Navy, is how easy you can make these drones. They are tired, everyone's tired of a development program that takes 20 or 30 years unless you're in a strategic space. So, and of course the cost of manufacturing eventually trickles down to people who could buy your system, you know, and trust me, your competitors in this space are definitely using modern manufacturing to drive their costs down. Example, this thing here is pretty much fully 3D printed, and everything that we do is 3D printed. Advances in resin and FDM printing can create complex structures for the fraction of the cost. And metal printing is a thing. The turbojets we use on the upgrade variants for that, a lot of the nozzles use a metal print, which is really cool. But yeah, you can do a lot with this now, and it's something if you're unfamiliar with it, you definitely should become familiar with it quickly, because you're not, the idea of doing a CAD model and shipping it to a fab house and coming back 2 weeks later is no longer viable. We had a part that we had to prototype at work this week actually, that went from a CAD fix to a part that was assembled in about 6 hours. So it was very impressive that what you can do with that now. You don't want to be waiting, and I think PCB design is kind of the next step up of the ability to fab PCBs and things like that is going to be the next type of printing we see, hopefully. I want one, so. So I've talked about this thing being a very short-lived thing. Asset lifetime is important, because if you're going to manufacture something that costs $1 billion, do you really want to blow up in 30 seconds? Is that really a good return on investment? You know, people who have taken engineering economics here, is that a good return on investment? Probably not. But if it might loiter for months and take pictures for months and come back alive, that's a lot better of an exchange. For example, the drone on the top right, the Shahid, there is one that's being used by Russia and Ukraine. It's a kamikaze drone, and it costs about 20 grand. So not that bad for someone that, you know, is not coming back. And shown on the bottom right is a repurposed commercial drone that Ukraine's using, the Mavic 3, about $2 grand there. Obviously, you know, the performance isn't like amazing. You know, the Ukrainian one has a 30-kilometer range, 6,000-meter max altitude. But for $2,000, you buy a bunch of those and you put some grenades or C4 or something, fly them around, and they do damage. They're still explosive. So, again, that's not to say that we don't make nice drones. That's not to say that there are not drones that cost, massive amounts of money that, stay up, that, cost that. It's just, you have to consider how long are you actually going to be flying this thing for it to be worth the price of investment to make it. And on the topic of asset lifetime, if your UAS is expensive and specialized in long duration, consider applying good stealth principles. Again, we have a very fun tech talk that talks about some of the principles of stealth design. And these include, but aren't really limited to material science, countermeasures, and airframe geometries. The RQ-170 is a fun thing that we don't really know much about, but it's believed to be a stealth drone with ISR. That's a Lockheed problem. But you can see, it's something that maybe you would want to have stealthy, and it probably does not cost, $2,000. If it did, then Lockheed's doing something incredible. So, and then navigations and communications. Does your UAS purpose put it in an area where it might lose GPS communications? If you're a military application, the answer is almost always yes. That's end of story. Depending on specifics, civilian UAS may suffer too in noisy environments, but, again, there's another good tech talk on electronic warfare, but now that this is so simple to produce and jamming is so easy, quote unquote, GPS denied and contested operations are a big deal. And I had a talk with a project office quite literally yesterday that spent an hour and a half grilling us on our GPS denied and GPS contested capabilities. So if you don't know what that means, it literally means what it sounds like. Your GPS is shut off, it's jammed, you don't have access to that, you don't have access to communications. What's your autonomy look like in that situation? Do you fall out of the sky? These are big deals because now that you can just, put something else that jams those frequencies easily, this is something you have to deal with. The vast majority of meaningful operations are going to be in these spaces. And by meaningful, I mean against something with even some form of proportional force. If you're bombing ostriches in Australia, then you probably don't have to worry about this. But, if you're attacking humans at this point, you're going to need this. And once these EW and other electromagnetic effects come into play, you really do have to consider inertia solutions and vision solutions. And we do have a vision-based navigation lecture too there, just really going out for our tech talks tonight. And GPS, while useful, isn't going to get you all the way. Even aside from the fact that you get jammed, GPS is only good to a handful of meters of precision. And you do need something, with higher fidelity, higher frequency, all of those fun things to really hit something if you're trying to do meaningful work. Most real systems use some form of sensor fusion that takes inputs from many sensors. Of course, the downside is you have to have those on board, which goes back to our trade space of, weight, power, all that fun stuff. So, and then going from there, autonomy, talking about GPS denied. What does your UAS do and how much autonomy does it have? Is it human in the loop? Does the human decide all the commands? Does it have a joystick of some guy across the planet that's telling it what to do? Is it human on the loop where a human can observe and intervene on automated commands if necessary? Is it off the loop? Is it fire and forget with no human involvement once launched? Is it you send it down range and whatever happens after that is outside of your control? And what level of independent decision making is acceptable? Can it decide a target without you? And that's our talk on ATR and automatic target recognition. And can it fire a weapon without you? And that's a link to a DoD standard I learned about recently that says, yes, it can. I was under the mistaken impression that a drone or automatic system had to have a human that said, hey, thumbs up, take that guy out. No, they can just decide that. So next time you see a drone ahead, remember that it has legal authority by the DoD to dust you for fun. So just keep that in mind. So going with autonomy, this is a nightmarish picture, by the way. This is what happens to Google, like swarm robotics, swarm drones on Google. I don't know what this scenario is. I don't know I don't know. That's an incredible amount of drones coming at you. So going from autonomy, you have teaming and swarming, different concepts, but similar. Teaming really refers to how do you collaborate with another UAS or an asset to complete an objective. Do you have one that's doing surveillance and reconnaissance and another that's taking something down? again, the hunter-killer mission profile. And swarming really is, you just throw a lot of things in the air that have very simple commands of complete a task and only understand vaguely that something is near them. They don't directly collaborate, they just have like sense of what's around them, and it gets an emergent behavior type of thing. A school of fish, a flock of birds, a swarm of something. So they're not, it's not collaborative necessarily, it's emergent. People use these in words interchangeably, but they're not quite the same thing. Again, something that there are people in the Army that care strongly about that distinction. And environmental, this one's a fun one. So where are you going to be flying? If your environments are hot, your computers won't be happy inside a metal tube unless you have some form of heat dissipation. And sometimes there is not enough heat dissipation. Computers in general shut down roughly 80 to 100 Celsius. That's when they give up the ghost for the most part. Some are a little bit lower. You can kind of see in the bottom right, that's capacity and voltage versus some temperature. So as your temperatures change, your overall voltage and capacity changes too. So if your battery, and you're relying on that drone to have that battery at a certain voltage, certain capacity, as you go through different environments, it's not going to be the same thing. And for my mechanical and aerospace friends in the room there, you suffer too. Metal has heat expansion. As you get really hot and really cold, that changes as well. And that's not really something you want at all. Can you imagine your airframe or wings changing size mid-flight because it got real hot? Yeah, that's not fun. Heat is always the enemy. You do not like heat, and heat really doesn't like you. And thankfully, temperature is not your only environmental concern. Dust and debris love to get in every aspect of your plane, much like they do everywhere. You can take off from a desert airfield. How's your air filter looking? Does it look like the one here in this car? Probably. You can get dust everywhere, and it gets into everything. Sand gets everywhere. What about flying through contested airspaces with flak? What happens then? You have a lot of metal bits in the air. Your plane really doesn't like that, even if it doesn't get hit. Smoke. If you have an air-breathing engine that's trying to assume a certain mixture of air and fuel to do combustion, it's not going to like that either. But water. Does your system enjoy getting wet? Does it like the rain? No, probably not. Everything about radiating heat in space or micro debris at orbital velocity, think about the X-47. There's a reason the space station has giant radiators, because without air to go over it, heat just kind of sits there. So you have to really try to radiate. And of course, if you're getting hit with something at orbital velocity, even a little screw, it kind of makes it hard to be tough. So going from there, maintenance, dirt, debris, heat, all of this are the enemy. How easy it is, how easy is it to fix and maintain all of this? And you really should aspire to have a tough system. We are, at least in the context of this, trying to make stuff that's good for military applications or something that's robust, rigorous for civilian applications. Don't make something so tough your technicians can't fix it, and they will thank you, trust me. And again, as a side note, listen to your techs. It doesn't matter if they have an engineering degree or not. A good tech would tell you why a part doesn't work. They may not tell you how to design it, they may not tell you why it works, but they're the ones getting their hands in there and telling you, hey, this bolt doesn't have the tolerance you think it is. Or the wire spacing and the wires are not, there's not room for those. And I've seen this be the death of multiple projects of, the CAD people made a perfect design, but does it have space for those heavy gauge wires for that high voltage? No, it doesn't. Yep. But so trust your techs and talk to them often if you have the ability to, because they will give you good advice. And they're usually pretty interesting people. I worked at one with Kratos who was a UAV pilot and a flight chief for, I think it was either the Predator or the Reaper. So there was a lot of interesting stories from him. Really interesting guy. A little crazy, but interesting. Refueling and resupply. So aside from maintenance and assuming your plane comes home or you want it to come home, because if something goes wrong and it has a bomb, you need to consider self-termination, which is in some cases fly into the ground or drop the bombs over the ocean, because do you really want a armed weapon to come back to your airfield? So how easy it is to get fuel and to resupply your system, how easy is it to get at the fueling port, what kind of fuel does it use, and how quick does it fuel? Does your turnaround time matter here? And again, don't have the fuel that's super special, combination that only you can make in your lab, because no soldier is going to thank you for that. They will say a lot of things, but it won't be complimentary. And then goes for payload. Does dropping a payload leave any leftovers on the aircraft? If this thing lands and it has something that it dropped a bomb, is there a part that has to be taken off and put back on? Or is it everything's gone, slide something new on and send it back up? And how quickly can you do that? You want your refueling to be simple, easy, not have to worry about it. As wonderful as I think techs are, they are not always people that, finished high school. We'll say that. So let's talk about this thing in front of y'all for a little bit. So what is this? This is Hellhound. This is a plane that I work on. I actually work on the bigger variant. There's some pictures of it there. But it's a family of unmanned aerial system vehicles made by Cummins Aerospace right here in Huntsville, Alabama. We have design engineers across the country, but all of our manufacturing is done right here at our office on the Redstone Gateway. 16 years of experience at the company, not me, but the company in general, focusing primarily strategic tactical missile defense, simulation, C2, and cyber activities. A lot of offices we've worked with, the Air Force Research Lab, MDA, NAVSEA. In 2019, Hellhound emerged as an idea by our chief engineer to design and build a platform for testing new and novel guidance and control schemes. He's a controls guy, and that's what he wanted to do. Since then, it has been in constant development and grown into 6 different variants with more in development. We have several patents associated with missile guidance and this airframe design. And we've had quite a few flight tests, a few that have crashed, and some hit tanks that we've done. So here we are, what's that, 6-7 years later? So this is the Hellhound S2/baseline. This was 2022-2023. It's a test platform, and it represented several key advancements over the original glider that would glide around, do all that, simply be a flight thing. This is the first fully 3D printed airframe. There's some carbon fiber rods in there and things that hold it together, but that is all 3D printed. We moved to a modular, open, object-oriented flight software approach, so it's not just, throwing a script in there that says make thing go. It also has a vertical TVC launch, and by that, I'll move up here and literally show it. Oh, that blinded me. It literally launches like this, and it has thrust vector control here, so it can do all that, launches up, and then hard over tilts, and then it goes. It's, what did I say the speed was? 250 miles per hour. That's how fast this bad boy goes. Hopefully that doesn't break if I set that back down. It's pretty tough, don't worry. And so vertical launches and 3D printed airframes have become a core capability of the Hellhound family. This is how we keep our costs down and how we rapidly iterate over designs. They would eventually evolve into a canister launch approach, so kind of a more man-portable idea of, you put a canister down and it just pops out of that, flies up and goes. And like I said, 3D printed parts allow for rapid iterative prototyping, 250 miles per hour, no kinetic payload, just a flight computer hardware communications, no bomb on this one, semi-autonomous, waypoints are uploaded during a pre-flight setup. Once launched, they execute the trajectory with no user interaction. You can terminate the flight. It has a ground control system, so you can take it down if you feel you need to. And if the data link is broken or leaves a geofence, kind of a don't leave this area, it self-terminates. On the right is our tank hit, and that's a really nice little still frame. You can see it up at the top there, but it'll straight down the barrel down into a wrecked tank at a flight test. So I looked for the video because public release, but I could only find the still frame, so I should have asked that. So that's the S2. This is what I look at every day. This is the S3 and the S3 Plus there, and as of 2024, these are deployable production vehicles. In addition to everything the S2 does, these variants include a higher max speed, 380 miles per hour, 600 kilometers per hour. I'll tell you a secret that number is on the low side. Max range of 40 kilometers, 40 kilometers, 24 miles out. A lot more focus on the internals with this one. It has both modular and swappable payloads. The nose cone at the front is a screw lock. So you screw it, pull it out, put a new one in. That's all it takes. And if you want to swap from electronic warfare to a warhead, that's all it takes. Very easy. It's literally 30 seconds. We have flown electronic warfare, successfully jamming things with it. We have flown warheads and are constantly developing new ones. We've done it with the GPS and a ATR Seeker, which is one of the things I'm very proud of. I was the main developer on that. The warhead's designed for soft targets, light armor, and anti-tank. As we've shown before, we can hit tanks, and now we have some beefier things to hit tanks with. And we're looking at some ISR variants that would include multiple cameras and loitering type activities. Supports some operation in GPS and contested environments. We have some nice little sensors that work with that. Ground, air, and sea launch capability because of the canister, and I think I have a canister video after this there. we're developing multi-launch capability, the ability to put multiple of these at a hard point and launch 2, 4, 6, 8, launch them off like little surface-to-air missiles. C2 and other tactical integrations. The S3, which is about 1.5 foot bigger than that thing, is about 15 pounds with an entire support package of 40 pounds, and it's about 30-ish K depending on how fancy you want to get. So you can see there, that's the launch out of the canister. It pops out, folds out, and spins, and I'm gonna hope this video doesn't like blast. We're gonna just mute that. That's our chief engineer, and you can see this was earlier this year there, out at Pendleton in Oregon. But it is a very impressive there. That spin is a result of centrifugal force, and you can see it hard tilt over and then fly off there. I think it reaches, I'm trying to think if I remember the max altitude, but I know that initial speed is into the 100 miles per hour there in a couple of seconds. I'll play that again just for funsies. Good old Chuck there. But yeah, that it literally, you ship it and buy it in that little canister, pop the top off, and within 2 or 3 minutes there, this thing can go. So a nice little fun turbojet. If it wasn't, bigger than that one, I would have, picked it up and brought it. But do I still have the, yeah. Oh God, where's the slideshow? Okay. Yeah, so that's the S3, and that's what I work on. I've built those myself there. I have done pretty much parts of every subsystem, electrical, mechanical, software. It's a pretty fun little project. So going from there, we have the S4 model in the back. That's about the size of this table. The scale is not great. The wingspan's about 45 inches, or 40 inches, 45 in length. This is the concept of extending our capability in the reach of Hellhound as a system even further, specifically for collaboration and trying to make things interact. Roughly 100 kilometer in simulations and roughly 280 for max speed. It's a little bit slower, but it goes quite a bit further. Also has a larger payload capacity, probably double what some of these others do. So you can put cameras, you can put things that make people not people anymore. A lot of emphasis on teaming, swarming, inter-asset communications, and spoilers, there's some future plans for things that are even bigger than this that might be in the triple digit or the quadruple digit for a range. Whole aircraft type thing there. So, very cool stuff we do there. If anyone's ever looking for internships there, keep an eye on LinkedIn. We do have open roles. So, a little bit of a summary there, and then we'll have some other fun stuff. The main thing I want to get across tonight is that these are complex systems, and they're made up of a lot of moving parts, sometimes quite literally moving. And it's pretty much impossible to be involved in engineering and not have some skill that is applicable to this. If you think you have that, I actually want to talk to you because I want to know more about that skill. I'm just out of my own curiosity. And non-engineering degrees and skills are also needed. We need people who do leadership and management. We need purchasing, business development, operators, pilots. Just because you don't feel like you can do calculus that well doesn't mean you're kicked out of this. We need people that do all spectrums of this. And hopefully you have some appreciation of some of the choices that go into this. So what do you do if you liked this? Like this field, like all of this there? Well, like I said, you can get some hobby grade fixed wing and rotorcraft on Amazon for almost nothing, $9 if you believe that one that had a lot of Photoshop on it. They can be, will they be good? If you buy cheap, no, they won't be. They'll be quite bad actually. But that's okay because you won't be a good pilot at first anyway. So if you buy a bunch of $9 drones, you're gonna feel less bad when you break them. They can be good and interesting for doing some reverse engineering. You may not get far with that, but it might be a fun project to buy a cheap one and crack it open, see if you can get into it. Might be fun. And while making a drone may seem daunting, they're not actually that hard to make. This here was built out of our chief engineer's garage, quite literally, the original prototypes there until it became a full-fledged product. And again, you can buy kits, your little FPV drones there now. They're not super expensive, and you can build your own for a handful of dollars. More fun ways to do it yourself. Get a 3D printer and learn to make wings and airframes. Follow the math if you're an aerospace engineer. Get a microcontroller, some IMU servos, and learn to make a control loop that stabilizes as you rotate it, because that's essentially how things turn when you're flying an aircraft. If you like flying, you can get the Part 107 drone pilot's license. You go down to the airport, take the test, and be certified as a drone pilot, and that is a way to make some money. This is a fast-moving field, and experimentation is an absolute must. All the interesting things you see coming out of various companies really do feel like the result of someone going, well, what if we just did this? Because it costs nothing and no one's gonna die when it crashes, you know, the old test pilot type of approach. A drive to experiment and learn would take you very far in this field. So, that's interesting clapping timing. So book-wise, AIAA, the American Institute of Aeronautics and Astronautics, has some great literature on aircraft, specifically UAS design. I brought two there. They cover many topics that are applicable to unmanned aerial systems and aircraft in general. For those interested in spending some money, those books are not cheap, but eBay is your friend sometimes. Some things I recommend that I've skimmed through that I like, you know, are listed here. The last two, the weaponeering and, you know, the tactical and strategic missile guidance, I call those my bad person books because they go into things like cluster munitions and stuff that really can do nasty things. But, you know, particularly with Hellhound, that's something we're doing. And Hellhound is a middle point of a drone and a missile. So, you know, if you're interested in something more in that space, the Kamikaze Loitering, those are good books. But really, any good aircraft design book, if you have a personal favorite, can be very applicable. Other suggestions are books on aerodynamics, control theory, communications, embedded software design, electronics, material science, and radar. Those links are links to various things that we have done with Tech Talks. We have a control theory and embedded software and some radar lectures. You know, any of the links here, I highly suggest you click those and, you know, maybe fill out the little form at the end saying what you're interested in learning more about, because, you know, me and Ethan know a lot of people that know a lot of things, and some that know less than that. Just a few acknowledgements, of course, you know, UAH, Ethan, and IEEE here for organizing this, and then Cummings for allowing me to use our plane as a teaching tool tonight. Q&A, yeah, I'll put the sign out, but I will be here for a little bit if people want to have questions, ask more about my career or drones, whatever. So
let's give it up for Sean. So there are links throughout the presentation. Obviously, you can't click them currently. If you fill out the sign-out sheet, everyone will get a copy of the slides. So we'll be able to dish those out so you can get any of the links. Other than that, while we're filling out the sign-in sheet, it is Q&A time. And feel free to come up and touch the drone so I can get good propaganda pictures. That's what I like to see.
Yeah, our company loves LinkedIn, so
Yeah.
if you want to, you know, the fodder pictures are always nice.
And Sean's good for
Yeah.
Q&A.
Is the Hellhound like hit to kill or active payload?
It
Or
is.
depends on which version.
It depends on what's on it. That one there that was used for the tank shot was a just pure kinetic there. It just hit it, but we have multiple warheads, armor penetrating blast frag type stuff that we've worked with to, you know, do things. Obviously, the blast frag is more helpful for counter UAS and softer targets, and the AP would be where the tank is, the anti-tank type of munition. So, you know, but it's designed in a way to be very flexible as needed. So, any other questions? Just the one about the bombs? Okay, I got a couple. Okay, so we'll start with here.
So you said the Hellhound is kind of like a middle ground between a missile and a drone. I know a lot of missiles are subsystems with drones. So I guess, like, what is the defining line in the sand between missile and drone?
For me, it's how it flies. That's why we say this. Our background as a company is very much into missile defense and missiles in general. So, you know, this launches, you know, and let's go back up there a little bit. You know, it launches like something you would expect to see out of a canister, out of a rail, like a Hellfire or, you know, a surface-to-air battery. So, you know, there's that. The speed too for this level of SUAS, something we hear a lot from some of our customers is the fact that we can push 400, you know, 300, 400 miles per hour is a nice benefit. You get away with being less stealthy because obviously, you know, it's plastic, all that, if you can outrun most things like bullets. You know, we were watching some videos as a company of, you know, in Ukraine, they'll go and, you know, pepper the sky with, you know, machine gun fire to take out, you know, those Shashi drones because they're moving at, you know, a quarter of the speed that we are. But, you know, are you really going to mathematically do the statistics of hitting that at 400 miles an hour with a bullet? Does that work out? You know, or have you spent like 1,000 rounds of ammunition? So, you know, and that's again a trade space of, you know, do you need to be stealthy if they have to expend a whole missile, heat-seeking missile to chase down your turbojet? So, you know, that's what I think kind of the middle ground of all of this is.
There's also one extra thing. Drones can land.
Drones can land. This lands.
Missiles can't land.
It lands nose first. Hopefully in someone. You know.
So that thing flies.
Yeah.
Like that.
Well, they took the turbojet.
Well, yeah.
out
I
of
mean,
it,
that,
but
not that one in particular. You know, because
if you put the turbojet in, it'll
yeah,
fly.
I mean, because you know that one, you know that model there, obviously.
Is that thrust vectoring
So-
installed in it?
It has the thrust vectoring shell.
You can
doesn't
see
have
the shell,
actuators.
but it doesn't have because it's all servo driven. But
Yeah.
you can see kind of on the backside there where the exhaust will come out, where it kind of. Yeah, so you can see here, there where it has
Oh, that's
a.
beautiful.
Yeah, it's all
So
Gets
these
into
would be your
nozzles,
attachment
not
points.
obviously
That's
for
sick.
the nozzle, the production nozzle. You know, it's a more of a metal print. You wouldn't want to like
Yeah.
use a nozzle with you know. There are very few you know
This is-
filaments that are going to tolerate that level of heat for you know
Yeah.
more than a moment.
I've seen like short burst engines use like Delrin, but that's like short burst.
No, we have to do metal because we do have some durations that go into the minutes and tens of minutes there. So
Anything over like 3 seconds, you
Yeah.
probably need metal.
I think there were two other questions.
okay, yeah.
Yeah, do you think that we might be looking at a similar revolution in unmanned ground systems?
Yeah, you do see some of that. The problem with that is ground targets are really easy to, you know, it's the same reason we won't get like, you know, like upright humanoid rocking robots because all you need is a plane with a missile to come by and that's the end of it. You know, there's a reason you see different tactics for like heavy armor like tanks being deployed, especially in Ukraine, when, you know, where was it? Yes. When that thing on the right can drop a grenade onto your tank and you've lost your like, you know, $1 million battle tank for $2,000 plus a grenade, you know, it's like, is that again, you know,
Really, it's just a grenade.
yeah, you
It's just
know,
the cost of a grenade.
yeah, you know, it's like it makes it hard for that to justify a thing, to be a thing. I know we've looked at working with some unmanned ground vehicles as launch platforms to support stuff like this, but there is an active effort in the Army and a lot of different project offices to support unmanned ground vehicles. You know, again, the ability to take humans out of the equation and the ability to deploy stuff, and especially for loitering type of even ground vehicles, the ability to just send something off down to the woods and say, oh, it's going to live there for a month now. And then when something happens, it comes out and does its thing. And, you know, most soldiers don't appreciate being told to go live in the woods for a month. Maybe some of them do, I don't know.
There
Or
is
some.
a large push for UUSs, which is unmanned underwater systems. So a lot of submarine drones, kind of like that. So imagine a kinetic suicide drone, except it's like a little submarine that sits under the water for months in your enemy's port. They didn't detect it, and then the second they're getting ready to do something big, you blow them out of the sky.
Imagine
Well,
the deep sea mines of World
Just
War
look
II.
up the manta ray.
The manta ray, yeah.
There's the Dive XLs out of Anduril coming out now. Australia just bought a bunch of those, and that's Northrop Grumman's Enterprise one, the Manta
Yeah.
Ray.
Yeah, so do they have undersea excellence there? UUV. Oh, do they have the video of it?
I think this video is ass.
Is it?
I don't even think it goes underwater. I think it just sits at the surface.
Wow.
Maybe it did go underwater. Yeah, I don't know.
I thought Northrop had money to do actual videos, Ethan.
They're not allowed to show off what it actually is for.
What, you mean it's not just a tourist device? No.
If you look up this thing, they don't even mention what it's for. It's like
Well, I mean,
it's like almost
it a
assuredly
DARPA
just gonna latch underwater and just wait to blow someone sky high.
I mean, it's a DARPA contract. We all
Yeah,
know.
it's
We all
DARPA.
know what it's for.
Oh yeah.
But you can look up check the Dive XL as well. That's an interesting one.
Is that Anduril?
Yeah, Australia just paid I think like $1 billion for like a bunch of these things out of Anduril.
Oh, that's a nice.
It literally looks like a
bonus.
submarine. It's pretty interesting. But yeah, this is becoming really big. The ocean is a lot of people discount it, but naval operations are arguably one
Yeah.
of the more important ones. Particularly considering a lot of the contested spaces coming up, Taiwan
I
Strait,
like
your
how
South China
they
Sea.
censor the prop on it. At the
You
end of
have
the video.
to.
I didn't realize that because when you watch at the end of the
Yeah,
video,
It's
it's
probably like some special.
No,
It probably is.
The shape of a
The shape
prop
of it.
Yeah,
lets you
that-
reverse
yeah,
engineer its
right.
acoustic signature.
yeah. See right here, they actually blur it out. That's
yeah,
funny.
so you can't for submarines. You have to.
They
If you've
show
ever
it
seen a
there.
submarine, they keep when it's out of the water for maintenance. They cover the props. It's because the shape is classified and the acoustic signature is the most important thing in submarine
Yeah.
stealth.
Yeah.
So you have to keep these things.
But
Functionally, submarines are invulnerable.
The cool part about all of this though is everything that we talked about tonight there as far as trade spaces and concepts. Yeah, this more or less applies to this too. Like anything unmanned, obviously there's some things that don't, apparently it elongates. That's pretty cool, I guess.
Yeah, same rules.
Yeah, like all of this is the same thing. I mean, there's a few things that are, not as, like not quite one-to-one. Obviously, you're not going to have an airframe for some things. You're not going to wear aerodynamics. You worry about fluid dynamics here. And unless your unmanned ground vehicle is really moving and grooving, aerodynamics is not something you care about. Let me see if they had an example of some of the ground vehicles we're using. Yeah, see, these are not aerodynamic at all. Like
The M60.
yeah. See, we've looked at things like this for Hellhound, solutions like this of, a mobile launch there, but most of these are not, they're fearsome looking. You don't want to see that coming at you.
That's one of the proposed
was
counter
it? Was
UAS
it-
systems is the gun turrets.
Was it Big Dog that had there are things like this there that,
Yeah, they weren't happy about that.
10K, wow. Interesting.
Yeah, when
Some
if
interesting
you
stuff
buy
there.
the Boston Dynamics one and you
Oh,
put like a weapon on it,
you
they'll
can get
say
you can get a 3D print too for it.
Yeah,
Big
they don't-
flamethrower.
they don't
Okay.
like when you do that.
They don't like when you do that? Damn.
Yeah, make
I
sure
can
you read
imagine.
the creative licenses if you rip something offline, because like if you get someone's like cool little robot dog off GitHub and you print it and then you put a gun on it and post a YouTube video, there's a very likely chance you're about to be sued into the ground. They don't like when their brand is associated with such thing.
Yeah. But
So tying a Glock to a drone, DJI drone, is not a very good idea.
That's illegal, straight up. But,
Yeah, that's the same thing. isn't it?
Battle Roomba.
Also, you can, as Sean mentioned, you can 3D print. You can do this stuff at the lowest cost ever, including making swarms.
Yes.
That's illegal.
That is you can't
Don't do that.
You can't do that.
It is illegal for you ever, without a direct FCC permission, to fly multiple drones at once, autonomous or not. So be very careful. There are videos of people doing it.
I mean,
They do not get permission.
you can straight up go and buy these. So
Yeah, so I know you mentioned that the S3 Hellhound was like 30 grand or more per one. How much is the S2 there?
You gonna jump them in the parking lot?
we could have a toss.
I know it's all 3D printed. You said it was all pretty much 90% of it was 3D printed, and that brings down the cost. So I mean, compared to the S3, which is 30
Because this was a prototype and we didn't sell these, I would probably estimate 5 to 15K. I mean, there is, jet fuel, the turbojet engines are off the shelf, they're COTS, but they cost money, filament, all
Also,
that.
he had a question then.
Yeah. What's the
What
question?
material did y'all end up picking for the outer shell?
For the current S3 we're selling, it's PET-G, but we're looking at other options because PET-G is only so strong. It has a carbon fiber rod type system, so that's actually like 5-ish% infill. It's quite literally a skin there, and all the rigidity comes from rods that go into it. So,
Are you guys planning to design anything with fiber optic cables?
it's not something we've talked about, but it's an
probably move too
interesting
fast.
idea. Yeah, I mean it's an interesting idea. I assume for like data rates, is that what you're thinking?
Have you
Or-
seen the Ukraine
Prevent
stuff?
getting jammed?
I have not.
They're jam proof because they run with like 20
Oh,
kilometers of fiber spool.
okay.
But
Make them like canisters that hook right to them now.
Yeah. They're moving far slower though.
Yeah.
If you attempted to do what they're doing, which is literal naked fiber,
Yeah, not.
if you turned right, it'd probably snap on the spot.
Yeah.
Yeah.
It'd be like
That's
fishing
wrong.
line and
Yeah.
whatnot.
I mean, but I've worked on tethered drones that were using fiber connections. Not this, but at Kratos we had Pegasus was a tethered drone that had fiber and high data rates going up and down it, which is pretty cool, honestly. That program didn't quite. We did our end of the bargain, and the other subcontractors decided not to. So
Yeah, so I know earlier you were mentioning loitering munitions, and since we got onto the fiber optic thing, so for the loitering munitions, are y'all talking like a drone that's just kind of deactivated for a little bit and then it'll start, or is it going to be? Because they've been, I know at least in Ukraine, they've been taking razor wire and doing miles of razor wire through the territories and just dropping that. Is that what you're talking about, or like how much or anything?
more of something that you can deploy. So it's a deployed asset that basically it wouldn't quite sit there, necessarily,
kinda
but
just
it,
circle.
yeah, kind of just circle like a vulture, and then someone can call in on a tactical net there. Hey, go take that guy down, and it drops out of the sky, and so yeah. So it's not quite. It's still active. It's still listening. It's just kind of in an idle, orbiting state. So, but there's a lot of contracts that are out there talking about that.
Pull up a high altitude pseudosatellite report. So there's a class of UASs that's between air and space called a high altitude pseudosatellite. They're a special class.
Yeah, these things
These are the solar
impressive.
powered planes. So these can fly for
Oh,
months
that's a
straight
better-
without
yeah.
refueling.
Yeah, blimps too.
And it's a small market right now, but it's growing fast. People are starting to use these as replacements for communication satellites.
Yeah, like I was talking about using quadcopters to put up like a cell network or a Wi-Fi network over disaster stuff. I mean, the ability to do all this and control your own thing. And of course, I guess there's plans for solar powered
Not the bloom.
Now you don't have to rely on huge quantities since they're passing you so fast in orbit. You have these sort of very slow flying drones that'll linger.
I will note though, funny enough, most stuff with drones is actually illegal. The FAA rules are rather strict.
There's a reason I
But they
linked to
have,
the Part
like-
107.
Yeah, they have like zero enforcement capability though. So like as long as you don't record yourself and post on the internet, there's like a 0% chance you're getting caught. So
The caveat
keep that
that
in mind.
Is that advice?
no. The proper advice is remember you live in Huntsville and anything you fly to the arsenal.
Yeah,
well,
they've got radars.
Yeah, they have radars and they
They'll
won't.
know.
Yes, they
Yeah,
know.
you gotta be careful about them. The FAA, they won't see nothing.
Yeah, I was in the Space Harbor Club here at UAH when I was an undergrad, and we did a lot of how to do balloon stuff. And if it looked like once things got cut loose that it was going over the arsenal, you had to make calls. Otherwise, UAH was getting visited, and there was a reasonable chance your scientific payload would get shot down by something.
Yeah.
Which we did GoPros on some of them, so we did kind of wonder that would be a pretty cool video.
Shot.
Yeah.
Survive.
Yeah, we got some Edge of Space stuff too there. So.
You would get it after
You just
battle.
get to watch the interceptor. Oh no.
Yeah, we got some cool Edge of Space video back then too there because I think got like 100,000 feet there when one got away from us. So we got some cool spinning at the, you can see the black of space and everything.
But if you were to print something like that, the overall filament cost is probably roughly $20 to $30.
Yeah.
And
About a
then
roll and
if
a
you
half.
were to replace the like high thrust commercial engine in there, the
EDF or something.
and put it in like
Yeah.
an EDF like $100, you can make stuff like this for $100, $200. It's really not that
The
difficult.
original prototypes before this there were quite literally carbon fiber printed frames with really thin plywood with motor on the back. It's just computer just like throw it, does it fly, and it did.
Some
and
of the
then we did
Russian Shaheeds that they have, they've
Yeah.
actually run out of the good ones, and they are now making them out of foam.
Which when you look at that, that's this guy here. There.
That's the
know.
good one from Iran.
Yeah, that's the good one. But
They've run out of those.
Well, of course.
So now they're making them out of foam. There was an incursion into Poland a couple weeks ago, and they captured some of them, and they were literally made of foam. It looked like they were trash, like straight up garbage.
Slow speeds, foam's pretty good.
It was. They did it on purpose too.
They're
Don't
not,
tell
they're
anyone,
not,
but
they're not bad
definitely-
drones. For 20K, the ability to drop at 110 pound payload, I mean, that's a small child with a bomb there. I mean, that's
Small? 110 pounds is small.
for American standards. Yeah. You had a question?
Is there like a absolute definition of what a swarm is, like 2 or more, 3 or more drones or something like that?
It's more than two, more than 2 or 3, I'd say. I mean, I would not personally say if I saw 2 drones coming at me, oh my god, that's a swarm. But if I saw, what was it? Yeah, this nasty thing, I'd be like, yeah, that's a swarm.
Funny enough, I think I know what that's from.
Is it from a
I
game
think
or a
those
movie?
are cruise missiles.
Are they? When you Google like swarm drones, they just give you this.
Yeah.
But they do look like cruise missiles. They kind of look like the L3s, like Red Wolf or whatever. They kind of look like that. Or Andurill's Barracuda.
They look more like the Lockheed Martin anti-ship missiles.
Well, I don't know what ship they're going after. That's a lot for one ship. I mean, that's a big,
Yeah, if you ever saw that, it's kind of over.
that's a big boat. It
Your
looks
only
like some
shot
Call
at
of
that
Duty.
point is to nuke the air.
Yeah, I mean, I thought it was from a video game, honestly, like Call of Duty or something. It looked like it might be something silly like that. So yeah, you had.
Oh yeah, I was just asking about this whole arm-based thing. Design a drone, there's countermeasures for it, there's countermeasures. So I guess, what are some of the I guess, countermeasures for like something like this? And were the iterations on the S3, S4, were those designed in response to the countermeasures that were developed, if any?
Yeah, it's supposed to.
I'll say obvious stuff just to not give away trade secrets. Lasers would fuck that up pretty good, right? Like you wouldn't build that. Like I mean, it's plastic. You're not gonna outrun that. I mean, anything. I mean, a missile, a heat-seeking missile, because it is a turbojet. There's obvious stuff there, right? Yeah, a jammer. Stuff like that. Things that that you don't outrun.
Not kinetic.
Yeah, not kinetic. There. Anything like
Except
that.
flak. I mean, I guess you could say flak would get it.
But then you run into the same problem as shooting a million bullets in the air of if you're in that space for a fraction of a second, 400 miles an hour, how quickly are you moving in a second?
If you've ever seen how CRAM operates, you'll know
you
that
would
it's
you
very
would need
expensive.
something like a CRAM,
It's
honestly.
the big minigun and it shoots a spray of them in front of it. Because even with good computers, good sensors, it's very difficult to actually land a bullet where something's going to be.
Yeah, one
Those
of
are fun to watch.
yeah
fire.
one of these there. You would need something like this that's a high velocity. What is that?
That's the German flak thing. Yeah.
Okay, that's cool.
But,
that would mess us
It's
up.
crazy that I knew it was German already.
Counter drone swarms there. So yeah, this one's
Yeah, it's
literally
like a
designed for
hyperflak.
that.
But the thing with the CRAM and even these guns, so currently from a counter UAS perspective, Sean showed it with some of the ground systems. A lot of people are investing money in the automated turrets because it's inexpensive, relatively. Bullets are relatively cheap, and you shoot a lot of them. You can still, because ultimately the ultimate fight here is this is a battle of economics.
Yeah.
Whoever can destroy the most for the least wins in the long run.
Yeah,
Because
again,
most wars just run forever.
Yeah, 20K versus 2K is a lot more sustainable as
Yeah.
a weapons.
So when you
base.
do the guns, though, the issue is you're going to be spraying a lot, and most guns actually have no way to actually reach the range necessary.
Yeah.
So if you look at something like CRAM, the bullets are like the size of my arm, like the full shell.
Yeah.
And I think one single burst is like $300,000. So you still win with a drone. If the CRAM takes your drone down, you still won
They're big bullets.
because you made them waste 30 times your drone's value.
Yeah.
So when I said the Russians with
Oh, there we go,
foam
yeah.
garbage,
Phalanx is
that foam
3,500
garbage still
per
had to be
second.
intercepted by an F-35.
Yeah.
So they won that engagement economically. You don't even need to destroy anything to win in the long run. You just have to waste their time.
You've seen that with Ukraine and Russia of, Russia's had to use all of their next gen tanks and aircraft and they've had attrition there. And it's like, yeah, and what is Ukraine lost in comparison to, trillions of rubles, I guess, there since the exchange rate's trash. Yeah. Whichever one they use there. Yeah, so.
I think he had a question.
Back in I was gonna say on that swarm picture, back in the early days of the SDI program, I was listening to a lunch and learn with one of the SMEs in the field, and his comment was very blunt. If the offense will always win if they have the means and the ability and the desire
This was
to
also funny.
apply the resources.
Yeah.
The
This was
goal
also
of
a funny
defense
swarm
is
there.
to make it 10%, is to kill one of theirs for 10% of the cost. Then you can win. You can the defense can win through attrition.
Mm-hmm. You had someone over there had a question? Yeah.
I don't know if you've seen the movie Angel Has Fallen with Morgan Freeman. Have you seen the drone swarm in it? How realistic do you think that is? Just put them a van and then they hide.
Realistic.
Oh yeah, you can just do that, yeah, for sure.
Yeah.
You can probably do that at home, not even trolling.
Again, you can.
Like straight up. It's not hard. So those are called switchblades. Look at the switchblade real quick.
Oh, is that what we
Yeah,
using that?
they modeled them after switchblades. So this is a drone manufactured by the United States and some of our allies.
Yeah, it's by AV.
So these are tube launchable. They're small, and you can see the wings flip out there. That was a recent test.
I know,
They
which is
tube launched
really
it off of
cool.
a Reaper, which is hilarious. Drone
Yeah.
deploy drone.
Yeah, it
But
oh, there we
these
go.
style
That's a
of
good
munitions are extremely popular because they can be put into those dense tubes, like
Yeah.
in that film. Yeah, these things are brutal. They've
Yeah, I
got
mean, this
normally
is-
the Switchblade was developed as something that like a dude would have in his backpack.
Yeah, literally like
And he would just be
this.
like, "Oh, I guess it's Switchblade time," and just let her rip.
Apparently, a lot of pictures of people just watching these in
Yeah,
stoic positions.
But that style of drone,
like
there's
a
people
Warner
on YouTube who have made legit, not even like that actual thing, for like $200.
Yeah, I mean.
So if you just put some explosives in there, it's another $200.
Yeah, because these are. Yeah.
You
I
can
mean,
get Tannerite at Dick's Sporting Goods.
Yeah.
true. That's true.
And remember, these are kamikaze drones
the
too,
200.
so these don't come back. You know, they're one-way trips there, so it's like, if you don't care, that's really what drives a lot of your costs of, do you care about getting this back at the end of the day?
Yep.
And the answer, you know, for something like this or a Switchblade is like, no, not really. You know, you make it cheap enough
And it's
there.
biodegradable.
Yeah, you know,
Well,
eventually.
the biggest issue, as was mentioned, is like the defense conundrum is it's almost always like comically complicated to intercept something, and it's really easy to bomb
Yeah,
something.
it's just really easy.
So
The
you're gonna
logs.
spend a lot of complexity, money, and time focusing on garbage, and then once they've depleted your resources, they'll send like a nuke at you or something, and you're just
Yeah.
cooked. So
The ability
it's a
to-
complicated space.
It is, and it's an interesting space because of that. So it's a lot of, the counter UAS space is very big. I can't think of,
Look up the Leonidas.
oh god, which one is that?
That's the high power microwave array. From
That's
Yeah,
that's an incredible picture, honestly.
that's a fake picture, but yeah, they actually do.
Or is it?
Really?
They have a real video of it taking down a collaborative drone swarm of about 30 drones. So this is one of the options that's being investigated, which is high energy microwaves. It basically just flies them out of the sky. There are problems with
Again,
this.
also
But
a
it's
really
marginally
great picture.
Didn't Serbia just use or I think it was Serbia that just used like one of the audio. Weapons against
Like, they
LRADs or
did some
whatever?
stuff with
Yeah.
crowd control, like in the
LRADs,
last day.
long range
LRADs,
acoustic
yeah.
devices. Yeah. You
I
can
saw
do that
that.
with this too. It works similarly.
I don't think you
The
won't be
phase-
blasted by this. It's microwave. I don't think you won't be blasted by this.
Oh, you'll just die of that.
Yeah, I think that just cooks you.
I was wondering if you could expand on the functionality of them in GPS-denied environments. Do these operate with the accumulation of sensor data with the use of Kalman filters and other computer vision techniques?
There's a lot of approaches, but typically in what I've seen done, when I was at Leidos, I was in their vision navigation group there, so I always think about, that's where I learned a lot of my knowledge from, and it's definitely vision common type thing. You know, even if you don't use vision, it's still common based. Honestly, at the end of the day, because you have to assume your state is now derived from something that is gone. But so, you know, the ability to say, oh, you have inertial measurements and GPS and vision and gravity and all these things to orient you there and be able to, you know, build up that track over time. I saw a really interesting video. We have a SME who focuses on EOIR, and he was showing me a video where they had done tracking with a common filter, but they had also counted in that track for like the last 30 states. So it was actually building like, oh, here's your location, here's your track on an object, and you know it's that object because you knew where it had been there. So yeah, a lot of it's common based. I think we did a lecture with the vision nav. I went in and I derived the common filter, and we did all that. That's one of these.
But from a denied environment, so there's solutions like that gentleman mentioned, where a lot of people are using like the cheap fiber spools.
Yeah.
That will basically prevent any type of jamming of that kind of stuff. However, you know, now you're tethered, so there are limits. But things like that high power microwave that was just shown, that's not actually jamming, that's just destroying the components directly. And then the idea that jamming is also a magic bullet, assuming they don't have the other solutions, is generally false. Jamming becomes ineffective, and particularly like the Russians, right, in Ukraine, very popular, they carry around these jammers to jam these things out. But the thing is, these jammers are not exactly agile. They're very focused on a direct band. And all it really took for the Ukrainians to really cause issues was have frequency agile transmitters. So they're just messing with the commercial drones and tweaking some parts, and now they can frequency hop, which makes it far more difficult to jam. Because the moment I can jump, particularly jump across wide bands of the spectrum and anywhere in between, you either need to know where I am, which is reactive, and then the second I start losing my signal, I jump again. So that's not gonna work. Or you have to barrage jam the entire band, which lowers the effectiveness as you're jamming at any given band, because you only have so much power. And of course, barrage jamming blocks you as well. So there are limits and issues.
And that's what something like a tethered drone. I didn't work on Atheon, but it was in the lab and we flew it there. But Pegasus was a similar concept of, you know, you put it on the back of a Humvee and it has a wire that, you know, can do all this nice stuff there. But it was carbon fiber, gigabit ether, fiber optic there. And so was Pegasus. But, you know, you get that 200 meters, I think is what we got. And it does, you know, ISR. It was designed to kind of go behind a Humvee and, like, you know, be in a contested environment, but give it still some situational awareness. And you know, with 1200 volts on those ESCs, you could probably put something fun on it from a laser perspective, at least something that did some, you know, blind to sensor, so.
But,
Do you guys have a homegrown autopilot, or do you use something open source like?
It's homegrown. Yeah, our chief engineer is, a big controls guy, has a master's in control theory, and he has a